All right, someone finally asked this question, which is great. This is the ultimate algebra simplification problem for this unit. If you haven't watched the video for problem number 5, the previous problem, I recommend looking at that. It's the same process, but the function's a lot easier because it doesn't have squaring and stuff in it. So you always see the idea, but here it is again. So what we're trying to do is simplify this difference quotient. And as I said in the other video, this has to do with slope. This actually is rise over run slope between 2 points on a curve, just like the average value, or average rate of change that we talked about in class. And so this makes up the sort of heart and soul of differential calculus, this idea of measuring slope, because this method of measuring slope makes sense even on things that aren't straight. And so that's, if you had to sum up differential calculus in a nutshell, you would say it's the, well, I don't know if you'd say that's really the whole thing in a nutshell, but a lot of differential calculus is based on the idea of using rise over run slope of curved things to measure the slope of those curved things. Anyway, so we're trying to calculate this thing, and so the main thing is just be patient. There's 3 parts to this. There's this f of x plus h. There's the f of x that we're subtracting, and then there's this division. And so the wise thing is to just take one thing at a time. So so rather than jump into the whole thing, I'm going to take just part of it. I'm going to say, well, what is f of x plus h? Let's worry about that first. So f of x plus h means that in the expression for f of x, I should replace all the x's with x plus h. So let's look at that to make sure we did it right. Here's f of x. So you see I have an x and an x and an x, and so each of those x's got replaced with x plus h. Now when I replace a single letter by something more complicated, I have to put parentheses around it because I do mean here minus 9 times all of whatever that is, and so if the x is something more complicated, I want to make sure I get minus 9 times the whole thing, and so that's what I have here, minus 9 times the whole thing. And the same thing here, instead of x squared, all of this squared. But this can be simplified. So to simplify this x plus h squared, that's really x plus h times x plus h. And if you don't remember the form of that squaring thing, then you can just multiply with FOIL, x plus h times x plus h. So you can kind of do that over here, x plus h times x plus h, using FOIL. And we can do that. And what you're going to get for that is x squared plus 2xh plus h squared. So that part is the same as x plus h squared. The next part, the minus 9 times x plus h, that's just a distributive property. The minus 9 gets multiplied through those parentheses. So I'll have minus 9x minus 9h. So this part is the same as this part. And then I have plus 6, so plus 6. So that's what I have for f of x plus h. And we could do a quick survey, but there are no 2 terms in that expansion that are the same. So there's no like terms that I can combine. In my difference quotient, that's part of it, and then I have minus f of x. So f of x, remember, is, I'll just write up here so I leave myself some room. F of x is just x squared minus 9x plus 6. So that's f of x, and this is f of x plus h. So in this expression that I'm really trying to simplify, I now have 2 of these 2 things simplified individually. So now I'm ready to tackle the whole thing. So I have f of x plus h minus f of x. Let me just write that better. F of x plus h minus f of x over h. So, and I'm going to use parentheses again. This f of x plus h is pretty complicated, so let me slap some parentheses around it just to make sure that I am keeping track of it. So that's, this whole thing is f of x plus h. I'm subtracting, again, parentheses, the expression that's up there for f of x. So again, this is f of x, so that's what I've written here. So it's the first thing minus the second thing, but I've used parentheses to indicate it's all of this minus all of that. and then that's divided by h. Now, one of the reasons that the difference quotient is, the difference quotient is measuring rise over run slope, but one reason that it's useful in developing calculus tools is that this difference quotient will simplify a lot. Notice that a lot of stuff subtracts away in the numerator before I do anything else. I have an x squared and a minus x squared. Right? So this x squared minus this x squared. So those subtract away from each other. Here's a minus 9x minus 9x. So again, this minus 9x is combined with minus 9x. That's negative 9x plus 9x. Gone. Here's a plus 6 minus a plus 6. So gone. And I think that's it. So lots of stuff subtract themselves away in the numerator. And now what I'm left with in the numerator is a lot simpler. It's 2xh plus h squared minus 9h. That's all that's in the numerator. It's not been canceled out. And that's divided by h. Now, it simplifies even more than that because in the numerator, I can factor out an h. Every term in the numerator has an h in it. All three of these terms have h's. And so I can factor out an h, and what I'll have left up there is 2x plus h minus 9. Now the reason for factoring out an h is that now I have a multiplication in the numerator and denominator. The numerator is h times this stuff, and the denominator is h times 1, essentially. Right? So you can think of that denominator as h times 1. And we said that if you have a common multiplicative factor of the numerator and denominator in a fraction, you can cancel them out. That's the only way you're allowed to cancel something from the numerator and something from the denominator, is if that something is multiplied by the whole numerator and multiplied by the whole denominator. So this simplifies in the end to 2x plus h minus 9. So this, this is not right. This was the answer. That's what the person who asked me the question had there. But the correct answer, the thing that should be in that box, is 9x plus h minus 9. So you can see that there's a lot to this. Individually, writing down this f of x plus h term, that's something that is just going to use FOIL and some care. So that's not crazy. And then being able to do this entire expression by keeping careful track of what you're placing where and canceling out like terms. Anyway, it's a challenge certainly, but it's not an impossible algebra simplification for you to do.